In last lecture we completed the divide and conquer. Now we are going to the next chapter, that is called as greedy technique. Greedy technique required few basics, right? Few basics required. So let me cover those basics. In those basics, major one is going to be heap sort, right? I am writing now. Heap sort. Right? So greedy technique, basics need basics, right? Primary one is going to be heap sort. In the I am repeating once again now. In greedy technique, you will use the heap sort, right? Again and again. Many times you will use. So it is better to clarify. It is better to clarify heap sort here itself. Right? Fine. I am starting now. Everything is ready? So I am starting. This is the basics which are required for the greedy technique. So I am starting now. See this one. This heap sort internally required. Many basics. Right? I am covering one by one. See the first one. What are the basics required? See the first one. Basics of heap sort. Many things are there. One by one. You will listen properly all these things. And one more thing I want to say to you. Right? In the last class I said to you. Now one more nice point I want to say to you. See this one. In the previous 10 years paper, if you see. If you see, right, from algorithm subject if you see, right, 10 years, almost if you see the previous 10 years paper, 15 questions are there from the heap sort. 10 years papers, if you see 15 questions are there. In some year 2 questions came, Linkut type questions, common data type questions, like that it came. So every year one is coming, sometimes Linkut type and right, common data type also came. So combinedly, last 10 years paper, 15 questions are there, right? Please be careful. It is a very important one, like merge sort, like quick sort, like heap sort. These three really important. Out of these three, guarantee, right, at least two will come. So forget about whether you will get the marks or not, forget about that story. Learn properly these three. This is also one of the very important thing in algorithm subject point of view. Right? Now I am starting See this one, heap sort basic things. Right? First one for the heap sort which is required, first one is going to be binary tree. I am starting from starting point onwards. For the heap sort, starting point required is binary tree. So everyone, what is the meaning of binary tree? Right? Binary tree means in the given tree, every node contain maximum 2 children. Not one node, two node. In the given tree, first of all it is a tree. In the given tree, every node contain maximum 2 children. See this one. He is having 2 children. He is having 2, but he is having 0. But still it is a binary tree because every node contain maximum 2 children. Right? It is a binary tree. Next one. It is also a binary tree. Right? You don't have child at all. Right? Maximum 2 children. Right? I think 0, there is no problem. It is also a binary tree. Next one. It is also a binary tree. Please be careful. Empty binary tree. It is a trivial binary tree which is empty binary tree. Right? Please be careful. It is an empty binary tree. Everything. Right? It is a tree. It is a binary tree. It is an empty binary tree. That's fine. So next one. Let's see this also. See this one. It is also a binary tree. But one thing. It is not a binary tree. What is the reason? More than 2 children are there. See this one. More than 2 children are there. It is not a binary tree. You know this very well. Only for namesake I said. I am repeating once again. For the heap sort, few basics required. First basic point, binary tree. So, binary tree definition, in the given tree, everyone contains maximum 2 children. It is a binary tree. It is an empty binary tree. It is a binary tree. It is also a binary tree, but it is not a binary tree. So, that is the binary tree definition. Everyone is fine now. Let's go to the one more thing. Right? 2. See the 2. Second point. Strict binary tree means in the given binary tree, every node contains, see this one. First of all, it is a binary tree. Strict binary tree, name itself saying, first of all, it is a binary tree. Right? Next one is going to be in the given binary tree, every node contain, right? Every node contain either 0 child or 2 child. Strict binary tree. In the given binary tree, every node contain 0 child or 2 child. But here it is not like that. Maximum 2 children. Maximum 2 means what? 0 or 1 or 2 is fine. But in the case of strict binary tree, every node contain either 0 child or 2 child. either 0 child or 2 child, right? Please be careful. That is strict binary tree definition, right? If you want, I will give you example also. See this one. It is strict binary tree. What is the reason? E is having 2, E is having 0, E is having 0. Next one. It is not a strict binary tree because E is having 1. Next one. It is a strict binary tree because E is having 0. Next one. See this one. Next one. It is also a strict binary tree because it is not failed. Not failed means pass only. It is a strict binary tree. It is not, right? It is a strict binary tree. It is also strict binary tree. Next one, what about this one? Let's check here. Year 2, no problem. Year 2, no problem. Year 2, no problem. Year 0, year 0, year 0, year 0, year 2, year 0. See, everywhere either 2 or 0. Everywhere either 2 or 0. That is called strict binary tree. In the given binary tree, everyone contain maximum 2 children. That is called a strict binary tree. Now let me say one more small line also. Listen, let me say one more small line also. You also after marriage behave like a strict binary tree. What is the meaning? You should have either 2 kids or no kid. Right? You also after marriage behave like a strict binary tree. What is the meaning? You should have either 2 kids or you don't have kids. Suppose if you have only 1 kid, you want to play, with whom you will play? Or you want to make him orphan, right? So you are marrying and you want kids. Yes, there is no doubt at all, right? You can go ahead, right? So the only thing what you have to do is either you should have 2 kids or no kid. No kid also no problem. 2 kids also no problem. Some people are asking 2 kids are there, what is the advantage, right? So when 2 kids are there, they both play with each other, right? They may play cricket, they may play tennis, they may play whatever they want, they will do. When 2 kids are there, they both become very close friends, right? They both will talk each other. What problem is there? They will say to their sibling. So it is better to have 2, right? If 1 is there, almost like you are making orphan. So my final thing what I want to say is, either you should have 2 kids or no kid, right? Some people may not like this one. It is your life. Do whatever nonsense you want. Right? Just I given my suggestion to you, right? Do whatever nonsense you want. You have 20 kids also, what is the problem to me? Right? 20, 30, whatever you want, you can follow. So every node should contain either 0 child or 2 child. That is called a strict binary tree. Right? I given one nice example also, right? Please you take care. Binary tree means every node contain maximum 2 children. Strict binary tree means everyone having either 0 or 2. Right? That is strict binary tree, that is fine. Let's go to the next one. See the next one now, 3. Make sure that everyone listen, 3. Almost complete binary tree. Almost complete binary tree. This is the third one. Just until now everyone, only for namesake I explained to you. These points you know very well. Right? Here 1 also possible, here 0 possible, 1 possible, 2 possible, but here 0 or 2 strict, name itself saying this is very strict, either 0 or 2, but here it is a normal binary tree, 0, 1 or 2, fine. Now come here now, almost complete binary tree. What is the meaning of almost complete binary tree? I am explaining, carefully listen, I am explaining. See this one, make sure that everyone listen, everyone make sure that everyone listen this one, see this one. Is it binary tree? Almost complete binary tree, I am explaining now. Is it binary tree? Yes. Because every node contains maximum 2 children. Is it binary tree or not? Yes, because he is having 1 child, no problem. He is having 0 child, no problem. It is a binary tree. Listen, it is a binary tree. But it is not a almost complete binary tree. Why? In the almost complete binary tree, one rule is there. What is that? Without completing left, don't go to right. Right? So first, almost complete binary tree is a first of all binary tree. But the condition is, without completing left, don't go to right. So, what is the answer? It is a binary tree, but it is not a almost complete binary tree. What is the reason? Almost complete binary tree definition is saying that if you want to go right, you can go, but after left only go right. So, I think this is the almost complete binary tree. What is the answer? See this one, right? After left only I will go right. If I don't go right, there is no problem. But one thing, after left only right. If at all you want to go, after left only right. So, what is the answer? It is a binary tree. It is a almost complete binary tree also. Right, let me give one more thing. See the one more example. See, make sure that everyone listen. See this one. See this one. See this one, is it binary tree? Is having one child, no problem. Is having one child, no problem. Is having 0, no problem. So it is a binary tree, that's okay. It is a binary tree, right? But it is not a almost complete binary tree. It is not a almost complete binary tree. What is the reason? In the almost complete binary tree, one rule is there. What is the rule? Right? So in the given binary tree, without completing one level, see this one, without completing one level fully, don't go to next level. What is the meaning? See this one, he went to the next level. Here gap is there. Why you went to next level? Right, almost complete binary tree saying that, right, in the previous levels without completing previous level, just don't go to the next level. See, in the previous level there is a gap. Why you went one more level? So it is a binary tree, it is not almost complete binary tree, but I will say when it is almost complete binary tree. See this one, left over, right over, right? Now see this one, this level is completely filled, then you can go to next level. But when you go to the next level, again same, without completing left, don't go to right. What is the answer? Left first, afterwards right. Here also left, afterwards right. You cannot go directly left here, right? Without left, don't go to right. After coming here again, without left, don't go to right. So it is a binary tree, it is an almost complete binary tree also. Right, what is the problem here? See, previous level is completely not filled. Why are you going next level? Here, left gap is there. Why are you going right? So these are the two conditions. Let me say easily now. Can you say, when can I say a binary tree is almost complete binary tree? What is the definition? In the given binary tree, right, at every node, in the not one place, two place, in the given binary tree, at every node, without completing left, don't go to right. And one more, right, without completing the previous level, don't go to next level. Without filling previous level fully, don't go to next level. Then I can say that it is almost complete binary tree. It is not almost complete binary tree because without left you are going right. See, without left you are going right, but it is a almost complete binary tree because after left I may go right, I may not go right. Next one, see this one, it is not a almost complete binary tree. The reason is, right, so previous level there is a gap. Why are you going next level? Right now, but it is almost complete binary tree. See this one, this level is full, then I will go next level. Next level also same story. What is the answer? Without completing left, don't go to right. In the given binary tree which will follow these two conditions, then it is known as almost complete binary tree. Now can you help me? Is it almost complete binary tree or not? Please verify. See this, is it almost complete binary tree or not? Can you say, is it almost complete binary tree? Yes. Next one, is it almost complete binary tree? Yes. Is it almost complete binary tree? Yes. See this one, because of all these previous levels are completely filled, then I am going next level. In the next level also, right, I cannot go here because without left, don't go to right. Here also again left, afterwards right. Is it almost complete binary tree? Yes. Is it almost complete binary tree? Yes. Can you say if I write right? No. After left only right. After left only right. So this is the almost complete binary tree. Now it is the correct time to ask you, is it almost complete binary tree? Yes, that is okay. If anyone asks you from today onwards, right, one of your friends said to you today onwards, I have a almost complete binary tree. In that almost complete binary tree, few gaps are there. Where? I have a almost complete binary tree, but in that almost complete binary tree, few gaps there. Where? In almost complete binary tree, if at all gaps there, that should be this one. That should be last level, means last level, this area, from right to left. In almost complete binary tree, previous levels no gaps, you know very well, because without completing previous, I cannot go to next two. And one more, without completing left, I cannot go right. That is the reason, in almost complete binary tree, if anyone say gaps are there, then what will you say? Last level, right to left, few gaps may be there. So can you help me? Is it almost complete binary tree? Yes. It is almost complete binary tree. In the almost complete binary tree, if at all gaps are there, last level, right to left gaps are there. See, please be careful. Last level, yes, right to left gaps are there. Left cannot be. Without completing left, I cannot go to right. Previous cannot be, because without completing previous, I don't go to the next level. So it is almost complete binary tree. And one more, if at all gaps are there, last level, right to left. And one more thing, in the last level, right, if at all gaps are there, in the almost complete binary tree, last level, right to left, it's okay. Suppose assume that in the last level, those gaps also not there. If at all there, last level, right to left, assume that those gaps also not there, then it is going to be complete binary tree. Almost complete binary tree saying that few gaps may be there. Almost complete, not complete, almost complete. Few gaps may be there. If there, last level, right to left. Supposing that those gaps also not there, it is going to be complete binary tree. So it is a complete binary tree. Now can you help me now? Is it almost, first of all try to remember, right? Almost complete, first of all try to complete binary tree is a almost complete binary tree. Every almost complete binary tree cannot be a complete binary tree, but every complete binary tree is a almost complete binary tree. I am repeating once again. Every almost cannot be a complete, but every complete is a almost. Right? I am thinking that you are okay. So this is a complete and almost also. If I remove this node, it is almost complete but not complete. Right? Fine. Can you say what is the almost complete definition? Without left, don't go to right. Without previous level, don't go to next level. Any binary tree which will satisfy those conditions, it is going to be almost complete. In the almost complete binary tree, last level few gaps may be there. Last level few gaps may be there. That is also from right last level right to left. Isn't that those gaps also not there? That is called a complete binary tree. That is called as complete binary tree. I'm thinking that you are absolutely fine. See this one. Until now, can you say what is the topic going on? Heap sort. Heap sort required what are the basics? All the things whatever I covered. Can you say first one binary tree? Next one strict binary tree. Next one right almost complete binary tree. Next one complete binary tree. What are the almost and complete difference? Both are almost similar, right? In the almost complete binary tree, last level right to left few gaps may be there, sometimes may not be there also, may be there, those gaps also not there. That is called complete binary tree. In some books, listen, this is the definition from Coreman. This is the definition from Coreman. Please be careful. Book to book, small changes may be there. In some other book maybe these two are complete binary tree. Right? In one book you want to say that this is also this one. This node not there, this node not there, then also a complete binary tree. This node there, then also a complete binary tree. You want to say that almost complete as complete only. Completely fill also complete. Few gaps also there, then also complete. In one of the book he is saying that total story is complete binary tree. Right? Just I am following Coreman, right? Because of that is a standard book, that is the story. Just to follow this one, right? So you don't do research on the books and all, right? One book, one standard book, follow blindly. The person who is giving question paper, if at all complete binary tree is something you want to ask, right? He will give definition. He will give definition. Every time he will give definition. If you don't give, just follow it, right? Fine. So I think binary tree is over, strict binary tree is over, almost complete binary tree and complete binary tree is completed. I'm thinking that you are okay. And one more, almost complete both will. If anyone asks you from today onwards, right, what is the almost and complete, you simply say completely fill. Say like that. If they ask you difference between them, then you can differentiate whatever I said. Almost means last level maybe few gaps will be there. Complete means, right, complete means those gaps also not there. This is according to Coreman. They comfortably you can follow, don't worry. Almost complete binary tree. So complete binary tree is almost complete binary tree where last level no gap. Fine, I'm thinking you are absolutely fine. Now see this one, right? See carefully. See carefully one more interesting line. See the interesting line. Let me take one complete binary tree. Whatever you got until now it's okay. Everyone know whatever I mentioned. Complete means complete, almost means few gaps may be there. So according to Coreman, one book is enough. Don't do research on every book. Not required also. Can you help me? It is a complete binary tree and almost complete binary tree also. Everyone fine. Let's see this. Let's see. See everyone. It is the level 1. Level 1 of the complete binary tree. It is the level 2 of the complete binary tree. It is the level 3 of the complete binary tree. It is the level 4 of the complete binary tree. Can you say totally how many levels are there? 4 levels. Right, the 4 level complete binary tree. Some students are saying that how can you say root as level 1? Why don't you take root as level 0? You can take root level 0, next one level 1 and so on. Then levels become 0 to 3 which will become 4. It doesn't matter from which number you will start. Finally how many levels there? Right, in this complete binary tree 4 levels there. Level 1, level 2, level 3 and so on level 4. 4 levels are there. Whether you take 0 to 3 or 1 to 4 it is up to you. Right, 4 level complete binary tree. Can you help me now? 4 level complete binary tree, it's okay. Can you help me now? First level, right? 4 level complete binary tree, it's okay. First level, how many nodes are there? 2 power 0. Next level, 2 power 1. Next one, 2 square. Next one, 2 cube. Right, 4 level complete binary tree. If you see the number of nodes, first level 2 power 0. Next one, 2 power 1. Next 2 square. Next 2 cube. Can you see total number of nodes? How many in 4 levels? See this one, total nodes. Total number of nodes. Total number of nodes is equal to, so what is the answer? 2 power 0. Total number of nodes in 4 level. In 4 level. complete binary tree. We are talking about complete binary tree. Total number of nodes in 4 level complete binary tree is equal to 2 power 0, 2 power 1, 2 square, 2 cube. I think what is the answer now? I think sum of 4 terms in the GP series. What is the formula? A into 1 into r power 2 power. How many times? 4 minus 1 by r minus 1, 2 minus 1. Which will goes to, what is the answer? 2 power 4 minus 1. 2 power 4 minus 1. So, total number of nodes in 4 level complete binary tree is equal to 2 power 4 minus 1. This is the way how this formula came. From now onwards, if anyone asks you, 4 level complete binary tree contain how many nodes? Simply 2 power 4 minus 1. Again I am asking you, 4 level complete binary tree contain total number of nodes how many? 2 power 4, because of 4 level, because of it is a complete, everywhere 2, 2, 2, 2, 2, like that 4 times. 2 power 4 minus 1. Why minus 1? First level only one node there, that may be minus 1. But actual thing, this series if you solve, you will get this formula. Right? 4 level complete binary tree contain 2 power 4 minus 1. How this formula came? Right? From this. How these came? From this. Right? I am thinking you are absolutely fine. Total number of nodes in 4 level complete binary tree contain these many. Now can you help me now? If you are okay, this entire story. Right, see this one, if you are okay this entire story, can you say in general, right, total number of nodes in k level complete binary tree is equal to 2 power k minus 1. Total number of nodes in k level complete binary tree is equal to 2 power k minus 1. So formula also this one. No need to by heart. Meaningfully I am saying just follow it. Total number of nodes in k level complete binary tree is equal to 2 power k minus 1. Right? See the next one. This is the first point. Right? First point. Now can you help me one small line? Listen, interesting answer. This is very difficult if you don't listen. This is very difficult. Let me say few lines. Can you help me now? K level complete binary tree contain total nodes how many? K level complete binary tree contain total nodes how many? 2 power k minus 1. Right? Listen, this is very tricky if you don't listen. Otherwise, you may do this mistake in the exam. So, I know what mistakes you will do also. When I feel that student may do mistake here, I used to repeat in the classroom many times. Right? I am repeating now. I am repeating carefully, listen. K level complete binary tree contain total number of nodes how many? 2 power k minus 1. Can you help me now? Is it minimum or maximum? K level complete binary contain total number of nodes 2 power k minus 1. Is it minimum or maximum? Try to remember, because of it is already complete. Right? Already complete. There is no minimum. Everything is that only. That is the reason. I didn't return minimum. I didn't return maximum. See this one. Total number of nodes in K level complete binary tree contain 2 power k minus 1. Is it minimum or maximum? Right? Everything that itself. Complete. In the complete, no gap is there. Where is the minimum? Where is the maximum? That itself everything. Please be careful. Right? So that itself, so that is the reason no maximum, no minimum. Total number of nodes in K level complete binary tree contain 2 power k minus 1. 2 power k minus 1 nodes. Is it minimum or maximum? Everything. So if you want, I will write every case. Please be careful. Next one more interesting answer. See this one more interesting answer. K level complete binary tree, this is the story. K level complete binary tree, this is the story. Can you help me now? K level binary tree contain maximum nodes how many? K level binary tree contain maximum nodes how many? Everyone know. K level binary tree maximum, everyone know. In all the binary trees, the binary tree which contain more nodes is complete only. Listen everyone now. K level binary tree maximum nodes. What is the meaning? 4 levels, you want the maximal binary tree, which is nothing but a complete binary tree only. 4 level binary tree contain maximum nodes how many? This only. Because everyone in all the binary trees are 4 level, maximum means what? Complete contain maximum. When you use complete, everything is himself. But when you say binary tree, minimum will come, maximum will come. Maximal binary tree, this is the answer. Right? So can you help me now? Same line. Can you help me now? Total number of nodes in K level complete binary tree, this answer. Total number of nodes in the K level complete binary tree minimum. Complete binary tree means minimum also same answer, maximum also same answer. In the place of the complete binary tree, if I say binary tree, then minimum maximum differ. Can you help me now? K level binary tree contain maximum how many? Okay, K level binary tree maximum. In all the binary trees, K levels, maximum one is going to be complete only. So that itself. Now the interesting answer. K level binary tree contain minimum nodes how many? K level binary tree contain minimum nodes how many? How many minimum nodes? Because of K level required, every level keep 1, 1, 1, 1. K level, I think K, right? Let me write now. So can you help me now? Same thing can be written like this one, same thing. See this one, total, right? This one, maximum number of nodes in K level binary tree, right? So when you say maximum binary tree, K level, this only, right? When you say complete, no maximum, no minimum, everything is this only, right? You know this very well. Can you help me now? Same story. See this one, same story. What is the answer here? Check here. Minimum number of nodes in K level binary tree. What is the answer? Because of K level, right? Every level keep 1, 1, 1. I think 1, 1, 1 like that, K times. So answer is K. Minimum number of nodes in K level binary tree. So K. Next one, minimum number of nodes in K level complete. In the complete, no minimum, no maximum. You know this very well, right? I am stressing again and again because I have to take care about all the people. I am thinking that you are absolutely fine, right? Now see this one, I think this may be first point. I think it is the first point, that is okay, right? It is the second point. Right, let's see the next one, third point. See this third point also. Mostly you are okay. See this third point also. See everyone now. Third point also. Minimum number of nodes in K level almost complete binary tree is equal to minimum number of nodes in K level almost complete binary tree is equal to. So K level, see this one, K level, everyone now, K level compulsory, minimum number of nodes in K level almost complete binary tree, right? See K levels compulsory, but you want minimum. See this one, listen everyone now. Until K minus 1 levels keep fully, but you want K levels, but you want minimum also. In the last level keep one node, in the kth level one node only. First level, you know, normal story, right? Until K minus 1 levels, it's a complete binary tree, right? Everyone, without filling the previous, how can you go to the next one? So almost complete binary tree rules, you know. So what he is saying is minimum number of nodes how many in K level almost complete binary tree, because of you want minimum and K levels also, right? So I think when you say almost complete binary tree, previously gaps not allowed. So until here full completely. So K minus 1 level fully you take, in the last level take 1. So what is the answer? K level complete binary tree 2 power K minus 1. Now K minus 1 level, what is the answer? 2 power K minus 1. This is going to be K minus 1 level, right? In the last level one more, which will goes to what is the answer? 2 power K minus 1. This is the answer. Minimum number of nodes in K level almost complete binary tree. Until K minus 1 level, do complete binary tree story first. Yes, I done. Next one, last level 1 plus 1. If you add them, 2 power K minus 1. Right? This is the minimum number of nodes in K level almost complete binary tree. I am thinking you are okay. Some people are asking, sir, maximum number of nodes in K level almost complete. Try to remember. When you say K level, see this one, K level binary tree or almost complete binary tree, any binary tree, K level, any binary tree, maximum is going to be complete story only. When you say maximum, you have to keep more. Binary tree more, which is going to be complete binary tree only. So 3 things I said to you, please take care. This formula many people knows, right? Next one is this one, right? Minimum number of nodes in K level, right? In K level binary tree, K. Next one, minimum number of nodes in K level almost complete binary tree. Because of it is almost complete binary tree, K level, before that, K minus 1 levels fully filled, right? This is the formula, right? But you want K levels, last level also. Some people are asking, last level, why are you taking 1, right? Why are you taking 1? If I don't take 1, then it will become K minus 1 levels. I have to take 1. Some people are asking, sir, why don't you keep more, but you want minimum? So this is the story. I am thinking that until now you are comfortable, right? Let's see one more small line also. One more small line is there. Let me take care of that also. See this one. Is it complete binary tree? Yes. See the answer. Is it a complete binary tree? Yes. Next one. See this one. It is a complete binary tree. It's okay. Can you help me? In this complete binary tree, how many nodes? Let me count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. In this complete binary tree, careful listen. In this complete binary tree, 15 nodes are there. In this complete binary tree, 15 nodes are there. Can you help me? What is the 15 by 2? In this complete binary tree, 15 nodes are there. I am okay. Can you say what is the 15 by 2? Right? 14 by 2 is 7. 15 by 2. What is the answer? 7.5. Right? 7.5. Take the ceiling value. 7.5. Take the ceiling value, not floor. Take the ceiling value. What is the answer? If fractions will come, complete binary tree contain 15 nodes. Just to do half, 7.5. Take the ceiling value. Then it will become 8. That 8 is going to be number of leaf nodes in complete binary tree. That 8 is going to be number of leaf nodes in complete binary tree. See 8. Next one, some people are asking, sir, total 15, if you remove 8, it is going to be what is this one? Leaf nodes or non-leaf? Leaf nodes. Right? Can you help me? From the 15, remove 8. What is the remaining? Remaining 7. 7 is going to be remaining 7. Otherwise, I will write here. Right? 15 minus 8, which will goes to 7. What is that one? Number of leaf nodes. Right? Number of non-leaf nodes. Non-leaf nodes. Right? Like this. So, if the complete binary tree contain 15 nodes, just to do half, fractions will come, take the ceiling value 8, so that is going to be leaf nodes. Remaining from the total, remove 8, right, which is going to be 7, it will go to be non-leaf nodes. These are non-leaf nodes. These are non-leaf nodes. Right? Fine. Now let me say one more small line. See this one. The thing whatever I discussed here, this is working for every binary tree or complete binary tree. See, complete binary tree. The story for complete binary tree. Some people are asking, what about this? Supposition that, isn't that this node not there? Can you say how many? Now it will become almost complete binary tree. In this almost complete binary tree, how many nodes are there? 14, because one node is gone. Can you say 14 by 2? What is the answer? 7. I think see this one. 7 leaf nodes are there. Please check. 7. Right? Non-leaves are same. Now let me ask one more. One more node delete. How many nodes are there? 13. What is the 13 by 2? 6.5. Right? 6.5. Take the ceiling value. What is the answer? 7. Right? 7 leaf nodes are there. Please check. Right? I think these are 6. This is also. What is the meaning of leaf node? 0 child. In the given tree, a node is said to be a leaf node if it contains 0 child. Levels doesn't matter, right? Number of children, how many? I think see everyone having 0 child, 6. I think in this level one more is there, 7, right? So 13 by 2 is 6.5. Take the ceiling value 7. So 7 leaf nodes are there. See this one? This is the 7 leaves. Right? Now, I think what I want to say indirectly, that the discussion whatever I done until now, that is not only for complete binary tree, for almost complete binary tree also it will work. Let me write the note. Until now, how many points I completed? 3 points I completed. See this also. See this one, 4th point. See the 4th point now. In n nodes, complete binary tree or almost complete binary tree contain, can you say leaf nodes how many? Leaf nodes how many? Everyone now? N nodes, right? N by 2, right? Leaf means ceiling value you take. Non-leaf, N by 2 floor. Some people are asking, sir, how I will remember, right? If anyone says, sir, I am unable to remember and all, if anyone say like that, nothing, right? Just to take one diagram and check. And even I also would see. That is the reason I took the diagram. That is the reason I took, right? Take the diagram and verify. You have doubt, floor or ceiling, take the diagram and check. So 15 nodes, 15 by 2, 7.5. Now I have doubt, can I take 7 or 8? Please count how many leaf nodes, right? One example. That is the reason. When you study any topic meaningfully, even though you forgotten, even though you have doubt, just you can, right, you can within few minutes you can easily see what is going on. Worst case, draw the diagram and check. If you remember directly, do that. If you are not remembered, take one diagram and check. Those people who will by heart, unfortunately they forget and assume, they don't know how to get it back. Those people who didn't forget, right, see this one, those people who didn't by hearted, they forgotten, just they will take one diagram and check. Meaningful things are always accepted. Meaningful things are always accepted. Please be careful. It is time consuming, right? I don't know all these things. Just to do meaningfully. Algorithm subject, if you don't study meaningfully, you don't get 1 mark also. There is no way, right? Please be careful. So, I think see, in n nodes complete binary tree or almost complete binary tree contain leaf nodes n by 2, non-leaf nodes are n by 2, floor, this is ceiling. Some people are asking, sir, this is working for almost also. I tried also, please see. 13 nodes are there, 13 by 2, 6.5, so 7 I took. So, see, 7 leaf, remaining is non-leaf. From the 13, if you remove 7, remaining whatever is there. What is the answer? 1, 2, 3, 4, 5, 6. 6 will be non-leaf. Right? That is also okay. I'm thinking that until now you are comfortable. See the one more interesting line. See the one more interesting line. See this? 5. Fifth point. See this also. If complete binary tree contain, carefully listen, if complete binary tree contain n nodes, if complete binary tree contain n nodes and k levels, if complete binary tree contain n nodes and k levels, now see what is the relation between them. Complete binary tree only, see this one. This is the formula where both will come, remaining all only complete. You know this meaningfully, you study. One thing also, please don't by heart. Little bit also doubt is there, take one diagram, whatever be I done. Please do like that. Those people who are by hearting, I am saying to you, you don't get anything. Right? See, when those people who are by hearting, after going to the exam, you know, lot of tension will be there. All the things which you by hearted, you may forget. Please remember, by hearting not advisable at all. Those people who will study meaningfully. If one exam, unfortunately, if you are unable to crack, right, next exam you will crack because you done meaningfully. Those people who done meaningfully, they are having lot of confidence. Those people who by hearted, they don't have confidence. See, those people who fail, right? Those people who didn't get the good gate rank, right? They are supposition that they are in dilemma, they are crying stage. The meaning of that one is going to be they by hearted. Some people, they didn't return the gate exam well. Gate exam unfortunately gone. Still they are laughing. The reason is they didn't by hearted anything. If not this, next one they will crack. Meaningful things are always advisable. Please try to get as meaningful as possible. Right? Fine. You know very well. If complete binary tree contain n nodes and k levels, can you say what is the relation between them? You know very well. Can you say if the complete binary tree contain k levels, total nodes how many? 2 power k minus 1. These are total nodes which is equal to n. If complete binary tree contain n nodes and k levels, right, then k levels are there, complete binary tree. Total nodes are 2 power k minus 1 which is equal to n. Then find out the k value. What is the answer? Right, this will goes to 2 power k is equal to n plus 1. Right, so apply log, it will become k log 2 base 2 is equal to log of, right, n plus 1, right, base 2. So k is this. If complete binary tree contain n nodes and k levels, so n is equal to 2 power k minus 1, 2 power k is equal to n plus 1, k is equal to log n plus 1 base 2. Right? So this is the way how to bring the number of levels and all. Now I think it is the correct time to ask you. Please listen. From today onwards, if anyone asks you, if complete binary tree contain 4 levels, total nodes how many? You know that formula. 2 power 4 minus 1, how many? 15. If levels given, total nodes you can bring. Supposing the total nodes are given, isn't that complete binary tree contain 15 nodes? How many levels? Just to do 15 plus 1, 16. Log 16 base 2, which will goes to 4. Right? So nodes given, levels you can find out. Levels given, nodes you can find out. Right? Both are same. Some people are asking, complete binary tree with n nodes, total levels how many? Log n plus 1 base 2. Some people are asking, complete binary tree with n levels, number of complete, see, I am repeating once again, complete binary tree with n nodes, total levels are log n plus 1 base 2. Why it came? You know, complete means what? Left half, right, balanced tree will come. Complete binary tree is a balanced tree. Next one, almost complete binary tree also balanced tree. Try to remember, because of one node missing, two node missing, don't say unbalanced and all. Right? You know what the meaning of unbalanced. What is the answer? All are right, nothing left. That is called unbalanced. Because of one node missing, don't say it's unbalanced and all. Right? Don't be right that much strict and all. Please be careful. Right? Complete binary tree, almost complete binary tree, both are balanced trees. Because of one node, two nodes, right? Don't say it is unbalanced. Unbalanced means no one on the right, all are left. Right? Fine. So this is the fifth formula. One thing also I am not by try to remember, I didn't by hearted one thing also. I don't know anything. Just I took one diagram, based on that I bring all the formulas. Is it floor value, ceiling value? I don't know. If anyone asks you suddenly, what is the answer for this one? Right? I will take one diagram and I will give the answer. Worst case. Best case, if I remember directly, I will say. If I don't remember, worst case, I will take the diagram and I will do that. Right? I am thinking that many things I written on the board. Many things, not one or two, many things. See this one by one. Just let's go roughly once. Now we are talking about heap sort basics, which need binary tree, means maximum 2 children's. Strict binary tree, 0 or 2 children's. Almost complete binary tree. Without left, don't go to right. Without completing previous level, don't go to next level. Right? That is almost complete binary tree. Next one. In the almost complete binary tree, if at all gap is there, last level right to left, assume that gap also not there. That is going to be complete binary tree. Now after this some story came. Right? See this one. Your complete binary tree. Complete binary tree contain 4 levels. Total nodes how many? Add all of them. Right? Formula you got 2 power 4 minus 1. Conclusion. K level 2 power k minus 1. Because of it the complete, maximum also same, minimum also same. Right? Suppose it isn't that it is not complete, it is a binary tree. In the binary tree, maximum is going to be this one only. Because in all binary trees, maximum one is going to be complete only. When you say complete, maximum minimum doesn't matter. But when you say binary tree, maximum minimum matter. Maximum is this, minimum is this. Minimum how? Every level keep 1 1. Right? That is okay. First point okay. See the second point. Minimum number of nodes in the K level almost complete binary tree. Because of it almost. Right? Minimum is asking. Last level few gaps are allowed. Right? But you want minimum, last level few gaps. Before that completely filled. This is the one. Last level 1 only. Because you want K levels. And minimum also plus 1. If you do that, 2 power k minus 1 will come. It is the third point. Right? Let's see the fourth point. This is the fourth point. N nodes are there. Complete binary tree, almost complete binary contain half leaf, half non-leaf. Fractions will come. Leaf will take ceiling. Next one. So relation between n and k. N is equal to 2 power k minus 1. K becomes log n plus 1 base 2. Final question I want to ask you. Final question. Please listen. Whoever can give answer, they can give. Please listen this. Please listen. Can you help me now? I have 15 nodes. I have 15 nodes. Make sure that you listen properly. I have 15 nodes. Right? How many levels will be there? How many minimum levels are there? 15 nodes I have. How many minimum levels are in the complete binary tree? What is the answer? 15 plus 1, 16. Log 16 base 2. What is the answer? 4. Minimum number of levels are 4. Maximum also 4 only because it is a complete. In the complete, minimum, maximum, everything same. Next one, can you help an interesting answer? With 15 nodes, with the 15 nodes, minimum levels how many? Minimum levels how many? How many levels? 15 nodes, minimum levels in the binary tree. Right? When you will get the minimum, 15 nodes are there, you want to get the minimum levels, keep everywhere maximum nodes, which is nothing but complete. 15 nodes, maximum number, listen, 15 nodes, minimum number of levels in the binary tree is going to be same like complete. 15 nodes, maximum number of levels are going to be, keep like this, right? Keep like this. 15 nodes, maximum number of levels in the binary tree. Keep every level 1 1. 15 will come. 15 will come. Right? 15 levels, minimum number of levels in the binary tree. What is the answer? Like complete. Next one. 15 nodes, maximum number of levels in the binary tree. 15. Right? 15. All these points one time you check. Because of complete, I didn't mention here minimum, maximum. Right? If it is a binary tree, I have to mention. Can you help me? If it is a binary tree, what is the answer? See this one. Binary tree contain n nodes and k levels. Binary tree contain n nodes and k levels. Can you say minimum number, right? N nodes and k levels. Then n is equal to 2 power k minus 1. Right? I cannot write. Right? Because of it is if it is a complete binary tree, everything this only. When it is a binary tree, I have to write here. Right? Minimum nodes, maximum nodes, something like that I have to write. Yeah. Please be comfortable with all the previous 5 points. They are mostly for complete binary tree. Small things about the binary tree also I mentioned, but mostly they are for complete binary tree. Right? Let's come to the next story. Please be careful. Whatever you got until now, it's okay. 5 points I clearly explained to you again and again. Now come to the next one. See everyone now. Binary tree representations are representations of binary tree. Both are same. Binary tree representations. The meaning of this line is going to be, you have a binary tree, you want to keep that binary tree inside computer. How will you keep? Right? So see this one, in my nodes, somewhere binary tree is there. I want to keep that binary tree inside computer. How I will keep? Right? That is called binary tree representations. Theoretically we will study binary tree on the papers and all, but inside computer I want to keep. How I will keep? Otherwise, to my program, I want to take binary tree as input. How I will take? That is called as binary tree representation. Right? So, two representations are there. First one is going to be array representation. Array representation. Second one is going to be linked list representation. To represent, I have a binary tree inside my nodes. I want to keep that particular binary tree inside the computer. How I will keep? That is called binary tree representation. There are two ways, array representation and linked list representation. Some people are asking, sir, what is the meaning of array representation? You know very well. I am writing one program. In that program, can I take array or not? Yes, I can take. Right? Next one, can I create in my program linked list or not? Yes, I can create. But when you know you can create the array inside your program, so using that also you can take binary tree. I think you can create linked list also inside your program. Right? Using linked list also you can take the binary tree. Two ways are there. Let me introduce the first way now. Right? Let me introduce first one. See, array representation how? Right? I am explaining this. Right? I am explaining the array representation. Afterwards we will see linked list representation. Right? See, array representation is going on. Let me write here. Array representation. So please be careful. This is very important topics. Array representation is very important one. Right? Please see this one. First example. Example 1. See the first example. So this is a binary tree. I want to represent this binary tree, right, inside a computer in the form of array. How I will represent? See, I am representing now. This binary tree you want to represent inside a computer, right, in the form of array. How? See, make sure that everyone listen, right? Everyone listen this. A. See this one. Take the first person. This binary tree inside computer in the form of array, how will you represent? I am representing now. Please see. So, A. Next one. Can you help me now? A, fine, it's okay. See this one. A index is 1. That's okay. Right? Can you help me now? What are the A two children's? First parent. Followed by their two children's. Right? Followed by their two children. Can you help me now? A two children's, who are those? B and C. Right? First to store A in the array, followed by their two children's. Though their two children are B and C, but first store left person, followed by right person. First store the root, after root over, their two children immediately, right, in that left child first, afterwards right. Now when this is done, A completed. How to store binary tree in the form of array? First step, store root. Next, root followed by their two children, in that left first, afterwards right. When you done that, then A is completed. In the similar way, go to B also. Can you help me? B followed by their two children. Who are those? What is the answer? D and E. B followed by their two children. Who are those? D and E. So, I think B completed means D and E completed. That's fine. Next one. C followed by their two children. Who are those? Right? F and G. Right? C also completed. Now, just do like that. First root followed by their two children, right? In that left first followed by right. After parent over, left once again. Again same story, continue until last element will come. Who is the last element? G. When you saw the last element G, stop it. When you saw the last element G, stop. So this is the answer. 4, 5, 6, 7, right, like that. Now, if anyone asks you from now onwards, how to represent binary tree in the form of array? First step, store the root. Next one, because of root you stored followed by their two children. In that left first followed by right. Right? Now next one, in both the children whoever came first to, right, to that person again, their two children, their two children, their two children, continue until last person will come. When you saw the last person, stop there. But some people are asking, sir, how you know who is the last person and all? Right? That is the meaning of array. Array is a static data structure. You should know who is the last. Array is not a dynamic data structure, it is a static data structure. You should know how many people are going to come. Everything you know. Static means what? You should know, you should have prior knowledge, right? So how many going to come? When you got to know is the last one, stop. This is the array representation. I am thinking that most probably everyone is comfortable, right? Let's see this one. See the interesting one. Let's see. I think, listen everyone, this is stored in the form of array like that, right? Please be careful. I am thinking you are comfortable. Let's see. See the one more line. See the one more small line is there. Please listen. 1, 2, 3. These are array indexes. 3, 4, 5. All the array indexes, whatever is there, those things I am writing. Now listen, one more interesting answer. See this one. One more interesting answer. Can you help you know? On the board, two diagrams are there, right? This binary tree and this array. Please listen. Inside computer, who is there? Inside computer, this binary tree is there or array there? Array only. Right? Tree is only for you. Inside computer, no tree, nothing. Every tree will be stored inside computer, either array or linked list. There is no tree, nothing. This is for user convenience. User is very happy by seeing this diagram. User may not happy by seeing this array, right? But one thing is by seeing this array, computer is happy. Right? This is for computer, this is for you. Please be careful. Both are okay. Both are okay. What is it? This is one for user, one for computer. Right? User is very happy with this diagram. Right? Can you help me one small line? Let me check. Can you help me now? If I give this diagram, see this one. You only say. If I give this diagram, if I ask you, who is the B parent? This is for user. This is for user. Can you help me now? If I give this diagram and if I ask you, who is the B parent? B parent is A. Who is the E parent? E parent is B. Who is the F parent? F parent is C. So, if I give this diagram and if I ask you who is the parent and all, you can easily say how? What is the reason? You have eyes, you can see. This tree is for you. If I give this tree and if I ask you who is the parent, you can easily say because you have eyes, two big eyes you have. You can see the diagram directly, you can give answer. Because the diagram is meant for you only, right? One more thing let me ask you. Can you help me now? What is the A left child? B. What is the A right child? C. Next one, B right child? E. C right child? G. Next one, F parent? C. D parent? B. So, if I give this diagram, if I ask who is the parent of someone, you can easily say. Who is the child of someone, left child of someone, you can easily say, right? So, this is for you. By seeing the diagram with the help of eyes, you can easily say who is the parent, who is the left child, who is the right child, everything. But try to remember, both are same. What is the meaning? Whatever is happening is here. Whatever is happening here also same thing happening. Whatever is happening here also same thing happened. The only thing is some other way. Let's check that also. Right? So, can you help me? Who is the E parent? B. Who is the B parent? A. What is the A right child? C. Whatever happening, same thing here also. I will check. Listen, I will check here. Make sure that everyone listen. And one more, this array index is starting from where? 1. This array index is starting from 1. Please be careful. I think everything ready. Let me say one small line. See this one. See everyone now. I am asking computer. This is for you. That's okay. I am asking computer. Who is the D parent? I am asking computer who is the D parent. This is there in the array. I am asking D, who is your parent? What the D will do is, can you say in the array what is the D index? 4. Right? In the array D index is 4. I am asking who is the parent of D? What this array representation will do is, parent of D means I think parent of 4 you want. If you want parent of 4, just divide 4 by 2. What is the answer? 2. Just do by 2. If you want to find out any person parent, by 2 you do. I think D parent is B. Please check. D parent is B. Fine. Next one. Can you help me one small line now? Who is the 6th parent? F, right? 6th place F is there. It's okay. Who is the 6th parent? What is the answer? 6 by 2. What is the answer? 3. So if you want parent, just do by 2. See this one, previous level. If you do by 2, what is the answer? Previous level you will go. See this one, I think it is the 4. By 2 if you do, previous level you go. If you have 6 by 2, 3, previous level. Parent will be there, previous level. Previous generation is parent, right? That is the reason by 2, right? Like that. Next one, some people are asking, one more interesting line. See this one, 7. Right, G is there in the 7th place. Can you help me now? G contain in the 7th place, it's okay. Who is the G parent? 7 by 2. What is the answer? 3.5. G parent I want to find out. 7 parent I want to find out. Can you say 7 by 2? 3.5. I have doubt. 7 by 2 is 3.5. I have doubt. Can I take 3 or 4? Because of 3.5. Can I take 3 or 4? Some doubt there. Please take one numerical example and check. Can you help me now? 7 by 2, 3.5. Can I take 3 or 4? 3. So take the floor value. That is the reason I drawn the diagram. Even I don't know. Right? So can you help me? 7 by 2, 3.5, take 3. Take the floor value. So G parent is going to be C. Can you help me now? Who is the 5 parent? 5 by 2, 2.5. Take the floor value 2. I think E parent is B. Right? Like that. But I'm thinking that if you want parent, just do by 2. Fractions will come. Take the floor value. Some people are asking, sir, how I know floor or ceiling? Take an example and check. Don't do anything by hearted manner. But one more thing, whatever is possible in this diagram, same thing possible here also. Both will be same. One for user, one for computer. Right? Fine. So I'm thinking that you are okay. Let's see one more interesting line. Let's see this also. This also you listen. See the interesting answer. Can you help me now? A position 1. Can you help me now? A position is 1, it's okay. But what about A left child? If you want children's will be there in the next level, not some other level, next level, not previous level, next level. If you want A children, next level means 1 into 2 you do. 1 into 2, 2. I think A left child is B. Right child, left and right will be side by side, plus 1. A left child is B, A right child is C, something like that. Those people who are thinking that, sir, I am not getting, can you check here also? Can you say, what about 3 left child, right? If you want children's next level, into 2 you do. 3 into 2, 6. I think C left child is F. Right child, plus 1. I think C left child F. C right child is going to be G. I think if you want, you can check. So if you want children, into 2 you do. You will get the left child. Plus 1 you do, right child. If you want parent means previous level, by 2. If you want children's next level, see the diagram. If you want children's next level means, I think more index required, multiply by 2. Right? If you want parent previous level means less index required, divide by 2. Right? Like that. I'm thinking you are okay. Right? Let me write those notes. Can you say topic name? Binary tree representation. How many ways? Array and linked list. Now what is going on? Array representation going on. First example. Whatever you are doing here, same thing is going on here also. Both will be similar. Right? If I ask who is the parent of B, A, here also I can do that. The only thing, different approaches. Here you see, this one no calculation. Why? With the help of eyes you can. This is not for computer, this is for you. But when you say computer cannot see, it will do calculation. Right? Fine. Now see this. See everyone now. So let me say few points are there. Let me say. See this one. If node is stored in ith place of the array, if node is stored in ith place of the array, then see the first point. If node is stored in ith place of the array, right? Then see this one. Then can you help me now? What about parent of I? If you want to find out parent, what should I do? I by 2 floor value. Small doubt is there, please check. 7 by 2, 3.5, take 3. Next one, 2. What about left child of I? Left child of I. What is the answer? 2 into I. So if you are okay, what about right child? What about right child of I? What is the answer? 2 into I plus 1. If node is stored in ith place of the array, then parent of I is equal to I by 2. Left child of I is going to be 2 into I. Right child of I is going to be 2 into I plus 1. Right? I am thinking you are okay. How to store binary tree inside computer. The reason is what? Binary tree means some people are thinking that binary tree will store inside computer like this only. No, this is for us, it is stored inside computer like this. But when you map this one to like this, right? How to find out who is the parent and who is the child? These formulas will give. These formulas will give who is the parent of whom, right? What about left child? What about right child, and so on. Right? I'm thinking that you are absolutely fine. Can you help me now? Whatever is possible in this diagram, in the array also possible or not? Yes, that is the meaning of both are equal. That is the meaning of both are equal. Suppose assume that whatever is possible here not possible. Assume. Then how both are equal? Something is missing. Everything possible by eyes with this diagram, right? This is possible inside computer. Inside computer is everything is right, calculations only. If I ask anyone who is the parent, directly they can say with the help of eyes. But here calculation they will do and they will say. If I want to say in the bad language, careful listen. If I want to say in the bad language, because some students like bad language like anything. They want bad language only. Let me say that also. If I want to say in the bad language, see the answer. Right? This is like India. This is like Indian culture or whatever it may be. This may be US culture. This may be the Indian culture. This may be US culture. Right? Some people are asking, sir, what is the meaning? What is the meaning? So if I ask any Indian, right, who is your parent and all, he will say directly, my papa is this. If I ask any Indian parent who is your child and all, they may say, he is my first child, he is my second child, like that. If I ask any Indian, they may say directly. If I ask US people, right, if I ask US people, right, who is your parent and all, right, then what they will do is instead of giving answer, they may say that, let me calculate first. They will calculate. If I ask any US person, right, who is your parent? Who is your left child? Who is your right child? If I ask any US person, instead of giving answer, they may say, let me calculate first. So they will do calculation, right? But Indians will give directly. But one thing, both will give. They will also say their mama, papa. Indians also will say their mama. The only thing is, someone, right? Some people will say directly. Some people will do calculation. Both are correct. Right? Fine. Some people want only bad language. Right? See, until now I said lot of story. Right? People are not happy. But when I say this bad language, they are very happy now. They are very happy. Okay, whatever. Right? Whatever. You are happy or not, it's okay. Just try to get this concept. So, binary tree, how to store in the form of array like this. Can you help me now? Parent of I by 2. Left child, 2 into I. Right child, 2 into I plus 1. Floor or ceiling, right? Floor. If you have small doubt, take one example and check. Right? Take one example and verify. I'm thinking you are okay. Right? And one more thing, see this one. See the interesting answer. In one of your previous paper, this question is given. They are asking, right? They are asking, if your binary tree is stored in the form of array, how to find out the parent of I? Right? What is the answer? I by 2. Floor or ceiling? Right? You may take floor, you may take ceiling, like that, right? You know, floor is the answer. But try to remember, in that problem they are given, right? Binary tree is stored in the form of array, where array index is starting from 0, not 1. This formula, whatever I written, starting from 1. If array index is starting from 0, small changes are there, take care. That is the reason, don't by heart. By heart the concept, not formulas. Okay, this is the concept. So starting from 1, this is the story, right? Starting from 0, same thing, only minor changes are there, please take care. In one of your previous paper, they are saying there is a binary tree which is stored in the form of array, where array index is starting from 0, not 1. Then how to find out? What is the formula to find out the parent of I? Right? If you say I by 2 floor, there may be a wrong. Please verify, is it working or not? If not working, just to do small addition, maybe -1. Maybe ceiling, maybe floor, I don't know, please verify. Starting from 1 I said, right? So please do starting from 0, minor changes. Some people are asking, sir, why don't you say 0 also? If I say 0, in one more examination, binary tree is stored in the form of array, where array index is starting from 2, then also I think once again small change. Right? Please be comfortable. It is a nice topic. Right? Storing binary tree in the form of array. One example I given, these are the formulas. Starting from 1, again and again I am reminding you. Yeah, let's see the second problem. Right? See the second. One problem I done, see the second problem. Example 2. Example 2, let me do this. So there is a binary tree. This binary tree if you store, see this one, this binary tree if you store in the form of array, this binary tree if you store in the form of array, at which index, right? So D will store. That is the question what is given in the previous paper. If you store this binary tree in the form of array, at which index D will store, right? So where array index is starting from 1 is given in the problem, right? Let's see. I am repeating once again, see the problem, right? Second problem is saying that in one of your previous paper, one binary tree is given and is asking if you store this binary tree, right, in the form of array, where array index is starting from 1, at which index D will store. That is the thing what they are asking, right? Let's try this, right? Let's try 1, 2, 3, 4. See, can you help me, right? Can you try? What is the answer? If we store this binary tree in the form of array where array index is starting from 1, at which index D will store, right? That is the given problem. Let's start now. Can you help me now? First A will store, followed by their 2 children in that left child first, B, C. Then I can say A is completed. A followed by their 2 children B and C. Now go to the B now, right? Go to the B now. Can you help me now? B followed by their 2 children. Who are those? In the B and C, B came first, so you have to take care about B. B followed by their 2 children, who are those? Right? Who are those? Is there any one or not there? Right? Not there. Try to remember. B followed by B 2 children's, right? So B followed by B 2 children should be there. If not there, say not there, keep the gap. B followed by B 2 children's, right? So there should be a 2 places, but because of not there, keep not there. Because of not there, keep not there. If there, right. If not there, keep the gap. Simply say B don't have. That is the meaning of that line. Next one. C followed by their 2 children. Who are those? D and E. D and E. Now see the position 4, 5, 6, 7. C followed by their 2 children. Who are those? D and E. Now next one. Whenever you see the last person E, stop. It is a static data structure. You should know who is the last one. E. Then stop it. So A followed by their 2 children B and C, in that B came first, B followed by their 2 children, right? Not there, say not there. If not there, see some people are doing this mistake. B followed by their 2 children not there. Whenever not there, instead of saying not there, they are writing, right, B children. So I am repeating once again. Right, see this one. A followed by their 2 children B and C, right? In that B and C, B first. Next one, B followed by their 2 children, right? Their 2 children. If not there, say not there. Some students what they are doing is, right? B followed by their 2 children, not there. Whenever not there, instead of saying not there, they are writing C children. You only say B children not there. How can you write? Right? When I ask you B children, how can you give the D children? Right? How can you give the C children? Please be careful. B don't have, say don't have. So when I ask you B children, instead of, right, whenever not there, say not there. Instead of saying not there, don't give C children, right? Please be careful. Again I am repeating now. See this one. A followed by A 2 children, B and C. In the B and C, first person B. B followed by their 2 children. If not there, say not there. Instead of saying not there, you cannot give C children. Please be careful. If you do that, some problem will happen. Those people who didn't kept gap, what mistake you done? B don't have children. Instead of saying not there, you are given C children. Then it is a serious problem. Some people are asking, what is the serious problem? Same thing happened to you. How much painful you are? Some people are asking, sir, what painful? So I ask you, see this one. Someone asks you, right? So who are your children? Someone asks you. Right? So you are a bachelor and you are not married, you don't have children. Instead of saying I don't have, right? You are taking the neighbor children and you are saying that they are my children. It is a serious problem. They will file a case on you. When someone asks you who are your 2 children, if you say, right, if you say I don't have because I am not married, that is okay. Instead of saying that, you are taking the neighbor children and you are saying that they are my children. If you do that, they will kill you and they will go to the jail. Please be careful. Not there, say not there. Those people who didn't kept gap, it is a serious crime. In human language, right, in the human relations, right, human relations will spoil because of these things only. Right, please, not there, say not there. So I think this is the correct status. This is the only mistake which is going to be expected. So those people who didn't kept the gap, that is a mistake. Please rectify. Please rectify. Now some students are asking me, now formula will work or not? Definitely formula will work. Why? Not there you are keeping two gaps. There you are keeping two, not there also you are keeping two. Some people are asking, sir, why I am keeping two gaps and all? That is the reason formula working. Why formula working? Parent by 2, children 2 into, right? Every time 2 will come. Every time this particular, see this one, array representation is designed in such a way that, right? So I think if you want the children 2 into, if you want parent by 2, always 2 will come. Always 2 will come. If it is a binary tree, that is the story. If it is a ternary tree, parent by 3 maybe. Verify yourself. Next one, right? In the ternary tree, first child 3 into I. Next one plus 1. Next one plus 2. Something like that. That may be. Please verify. Right? So that is the reason. So whenever you are representing this one, not there, keep 2 gaps. There 2. Not there 2. That is the reason formula working. If anyone don't keep like this, formula don't work, means you done wrong. Formula should work. Formula should work. Formula not working, then how can you find out the parent and all? Right? Please be careful. If anyone done like this one, so this is the mistake. Please see. If anyone done like this one, this is the mistake. So A followed by their 2 children, B and C. B followed by their 2 children, right? Not there. Instead of keeping 2 gaps, you didn't kept any. Not there, you left out. Right? Next one. So completed. You didn't kept gap also. C followed by their 2 children. Who are those? D and D. You kept like this. See the problem. 1, 2, 3, 4, 5. Right? Like this. Actually B don't have, instead of saying B don't have, you kept the C children. Right? Maybe there may be some problem. Some people are asking, sir, what is the problem? Let me check here. Let me check. Can you help now? What about the, right, D? D is 4. Who is the 4 parent? 4 by 2, 2. D parent is B. See this one. D parent is actually C. Because of you done wrong. D parent is B. Right? This is the mistake. I asked the D, who is your parent? Instead of saying C, he said B. He said B. Right? It is a serious crime. Same thing happened to you. It will be really painful to you also. Some people are asking, sir, how pain will come? You came from office and you are asking, after few years, assume that you marry, you have the kids also. You came from office and you are asking one of your kid, beta, who is your papa? Right? When you say like this one, right, instead of saying you, he's shown the neighbor, you will feel so painful. If you think that is pain, this is also pain. This is also pain. Please be careful. If anyone done this mistake, I am again and again asking you, please don't do this. Right? This is wrong. I given many examples also. If you think that is wrong in the human life, here also same. Here also same. This is wrong. Why formula not working? You didn't follow it properly. That is the reason this mistake is happened. Here, see, you followed properly. Not there 2 gaps. There also 2 gap. Not there also 2 gap. If you want, you can check now. Can you help me now? Who is the 6 parent? 6 by 2, 3. D parent C. See this. Can you say who is the E parent? 7 by 2, 3.5, 3. E parent is C. Yes. Next one, can you help me now? What is the B left child? 2 into 2, 4. Not there. Plus 1, right child also not there. Can you say what is the C left child? 2 into 3, 6. D. Right child plus 1. Like that. I think everywhere formula is working. If you do that, formula may not work. Why? You violated one of the rule. So to this problem, what is the problem here? If we store this binary tree in the form of array, where array index is starting from 1, what will be the position of D? What is the D position? 6 will be there. D position is not 4. D position is 6. Right? I think you are okay. When can you say your answer is correct answer? Formula working, then your correct answer. Formula not working means somewhere you done a mistake. Right? Fine. Now you are okay. Let's go to the next one now. Example 3. You are okay. Whatever you got, it's okay. See this one. If I said anything bad language, any bad language, if I said to you, right? Please make sure that think positively. To make sure that everyone is comfortable. Maybe I said that. Right? I don't have any intention like this. Right? Maybe I said the reason is, right, so that some people will get bad language immediately. Good language they may not get. Bad language, everything they got okay. Right? In array, right? Everywhere 2 gaps required. Otherwise this problem will come. They will remember many days. Fine. Take everything positively. Right? Now go to the next one. Example 3. Example 3. I'm starting this problem also. Take care. right? So A, C, B, D. So this binary tree if you store in the form of array, what will be the answer? Please carefully you write. What is the story going on here? Representing binary tree in the form of array, how? Small mistakes are going on, rectify. Right, let me start writing. So what is the first one? A. Right, so everyone know this one. It's very simple, just listen now. This binary tree if you store in the form of array, what is the answer I am writing now? A first. Right, followed by their two children. Who are those? C and not there, means gap. Everyone should have 2. If you don't write 2, that formula don't work. If there, write the 2. If not there, keep 2 gaps. 1 is there, keep 1 only. Next one is gap. A followed by 2 children, C and gap. Next one, I think A over. Next one, C followed by their 2 children. Who are those? C followed by their 2 children. Who are those? B and gap. C also over. Next one, gap followed by 2 children. Not there, so 2 gaps. Right, 2 gaps. Next one, B followed by their 2 children. Who are those? See the interesting answer. This is the mistake what people are doing. B followed by their 2 children. Who are those? See the interesting one. This is the interesting one. B followed by their 2 children. What is the answer? D and gap. D and gap. But when you saw the last one, stop. When your story over, there is no requirement of 2. D for, right, so see this one, B 2 children are D and gap. I want to write also, but unfortunately, right, array is over. There is no requirement of going further. If it is the case, to him also I have to write 2 children. To him also I should write the 2 children. To him also I should write the 2 children. Please be careful. B followed by 2 children. D and gap. But when I am going, okay, it is completed. When you saw the last person, stop. So what is the answer? 1, 2, 3, 4, 5, 6, 7, 8. There is no 9. Please be careful. There is no 9. Why there is no 9? When you say tree over, what purpose you are taking further? So, see this one, in one of your previous paper, this question is given. If you want to store this binary tree in the form of array, what will be the array size? Array size is 8, not 9. Please be careful. This tree, if you store in the form of a, right, in the form of array, what will be the array size? Array size is 8, but not 9. Right? See this one afterwards, when D came, stop it. This is the third example. Let's go to the fourth. Let's go to the fourth one. See the fourth example also. Example 4. A, C, D, B. This binary tree if you store in the form of array, what will be the answer? Just verify. Right. See the fourth example. So if you can give correct answer to this problem, right, mostly you got the array representation. So I am starting now. See this one. This particular binary tree if you store in the form of array, what will be the answer? See the answer now. As usual, what is the answer? A followed by 2 children. Who are those? Gap and C. Gap and C. Then A completed. Gap and C. Next one. So gap followed by 2 children. 2 gaps. Next one, C followed by 2 children. Who are those? Gap and D. Next one, I think C also over. Next one, I think C. C what is the answer? Gap and D. I done already. Some people are asking, sir, why don't you stop now? There is one more also. See, B also required. Please be careful. Because of still something is left out, I am continuing further. C followed by 2 children. Who are those? Gap and D. That is okay. Next one, after C, next one. After C, next one, gap. Gap followed by 2 children, 2 gaps. Next one, gap followed by 2 children, 2 gaps. Next one, gap followed by 2 children, 2 gaps. Next one, D followed by 2 children. Who are those? D followed by 2 children. Who are those? Gap and B. Right, gap and B, but when you saw the last one, stop it. D followed by 2 children's gap and B. When you saw the last person, stop. So see this one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Right, like this. I am thinking you are comfortable. Right. So see this one. How many slots total? How many slots total? So 1 to 15. So 15 slots. So, and one more thing I want to ask, in this binary tree, how many levels there? Actually 4 nodes are there, it's okay, but how many levels there? 4 levels. 4 levels are there. 4 levels are there, right? In every level 1 1 only on the rightmost path, that's okay. Total slots required is I think almost like 2 power 4 minus 1. How many? 15 slots required. See this, roughly like this. So it is the fourth example. It is the fourth example, right? So for the fourth example, this is the answer, right? For the third example, it is the answer. In every problem, something new I said. Can you see in this problem what is the new I said? See this one. If at all not there, you have to say not there. If you say, if you don't say, some problems will come. Next one, right? I think after this problem, this one is came. Some people what they are doing is, for the last person, B followed by 2 children, D and gap. When you saw the last person, stop it. Don't go further. Right? After last one, right? How many gaps you will keep? Last one you see, don't keep further. Go to the fourth example. In the fourth example, nice one. So I think almost like 15 slots required. 4 level tree, every level 1 1 1 only. 4 level tree, every level 1 1, 4 nodes only there. But to represent that in the form of array, 15 slots required. 15 slots required. Can you help in what the first problem? See, first problem. This is the first problem. In the first problem, see, 7 nodes are there. 7 slots are enough. In the first problem, 7 nodes are there. 7 slots enough. Right? But in the second problem, third problem, if you observe all, right, I think a little bit of more space required. Second problem, if you observe how many nodes there? 5. But how many slots required? 1 to 7, 7 slots required. Right? So I think third problem, right, like this. Only 4 nodes are there. How many slots required? I think 8 slots required. So in the fourth problem, 4 nodes are there, 15 slots required. If you really okay, see this one, if you really okay, this entire story, all 4 examples, please be careful, and let me simplify further also. All 4 examples, first example is there in another slide, right? So totally 4 examples if you observe, see the note I am writing, see the note, see everyone now. To represent, see this one, this is given in one of the previous paper. To represent n nodes binary tree, in array format. To represent n nodes binary tree in array format. Right, array format. Can you help me now? To represent n nodes binary tree in array format, right? What is the minimum size array required? What is the maximum size array required? See this one. To represent n node binary tree contain n nodes. To represent n nodes binary tree, right, in array format, right? What is the minimum size array required? What is the maximum size array required? In one of your previous paper, they are asking. Can you say what is the minimum size array required? Minimum. What is the maximum size array required? N nodes binary tree to represent in the form of array, what is the minimum size array required, what is the maximum size array required. So what is the answer? See the first problem. See, 7 nodes are there, minimum 7 required. See this one, 7 nodes, 7, minimum is this, minimum. If you are lucky, 7 nodes, 7 slots are enough. You are lucky, that is the meaning. Can you help me now? This representation is the best idea when 7 nodes, 7 slots are enough. Minimum is this only. 7 nodes, 7 slot. This representation is the best idea when, if the given tree is a complete binary tree. It is a complete binary tree. See, in the tree, no gaps. In the given tree if the given tree is a complete binary tree or almost complete binary tree. Why? In the last level, see, after last node gaps are there. I don't bother. No gap at all, it's okay, this representation is best too. Gap is there after last node, then also okay, because what is the meaning after last node? Binary tree is over, afterwards gap is there or not, how it matters. This representation is the best idea if the given tree is a complete binary tree or almost complete binary tree. Why? N nodes are there, n slots enough, this is the example. Right? Fine, see this. Minimum is going to be n nodes binary tree to represent minimum size array required, n. Can you say what is the maximum size array required? See the maximum size. See, 4 nodes are there. Rightmost place, see, left side, so many gaps are there. Right? It is the maximum size array required. Maximum. If you are unlucky, it will happen. So what is the answer? 2 power n minus 1. To represent n nodes binary tree in array format, minimum size array required is n, maximum size array required is 2 power n minus 1. When minimum possible? Complete binary tree or almost complete binary? Let me write. Complete binary tree or almost complete binary tree. Right? So minimum will come. Maximum, I think all are going right side, left so many gaps, right? This much space is required. By seeing all these examples, please help me now, right? Array format is better when, if the given tree is a complete binary tree or almost complete binary tree, then array format is better, otherwise linked list. Now listen, it is something like this one. Some people are asking, sir, in the gate examination one binary tree is given. They are asking to represent this binary tree, which representation is the best idea. What is the answer? If at all, if you got to know, given tree is a complete binary tree or almost complete binary tree, right? Then go for, right, array format. Otherwise go to linked list. Otherwise means, see, binary, see this one, complete binary tree or almost complete binary tree is very rare incident. Right? Other than that means what? Most of the time, other than that only will happen. It is a very rare incident. Right? Until unless they will say complete binary tree or almost complete binary tree, don't go to array. Right? Go to linked list. Go to linked list. In the linked list, no need to take more space, no need to take less space. How many nodes are there? Those many. Because of the linked list, random access may not be possible. It is a linked list, random access may not be possible. How to find out parent of someone? Right? It may not be possible. Right? So that is the only problem. Every data structure having its own advantage, its own plus and its own minus. Right? Please be careful. Last one. Array representation is better for what kind of binary trees? Complete binary tree or almost complete binary tree? Let me write that note also. Please be careful this problem. To represent n nodes binary tree, right, in array format, minimum size array required is this one, maximum size array required this one. I think from this conclusion, see this one, from this conclusion, array representation is best idea. Array representation is best if given binary tree is complete binary tree or almost complete binary tree. Array representation is best if given binary tree is complete binary tree or almost complete binary tree. Otherwise linked list better. Otherwise linked list better. Fine. That is the story. To represent n node binary tree in array format, minimum is that much, maximum is this much. Array representation is best if given a binary tree is complete binary tree or almost complete binary tree. Otherwise linked list is better. I am thinking all these things are okay. Right? Now can you help me know what the current topic is going on? Right? I want to explain the heap sort. For that some basics required. I explain in those basics what is the one of the basic point, representation of binary trees. Right? How you represented array format. What is the one more representation? Linked list format. In the linked list format, will you take the more space or less space? In the linked list format, will you take more space or less space? How many nodes are there? That much, right? Those many. How many nodes are there? Those many nodes only I will create using linked list. In the linked list chapter, anyhow you will see that. Don't worry. That is the reason I am not explaining, right? So only for complete binary tree or almost complete binary tree, array representation is better. Otherwise linked list. In the linked list chapter, we will see that. Linked list, n nodes binary tree. If you create the linked list, n nodes are enough. It don't have random access, but array having random access. Array may be having some space problem, but that also okay. When complete binary tree, almost complete binary tree, that problem also not there. Otherwise, space problems will come. If you want to eliminate, then go to linked list. Right? You are okay now. Please take care about all these 4 problems. Right? Now let's come to the next story. For the heap sort, all the basics which are required, we completed. It is the correct time to go to the heap sort. Please take care. This is a very, very important sorting technique. Especially in gate examination point of view, I don't know why he like the heap sort that much. I really don't know, but every time it is coming. In total, it is one. In total algorithm subject, the easiest topic is going to be heap sort only. There is no great logics also. Basics you should know. That is the reason from basic point onwards I started. From where I started? What is the binary tree? What is the strict binary tree? What is the almost complete binary tree? What is the complete binary tree? Next one. How to represent binary tree inside a computer in the form of array. All basics I done. Right? Now it is the correct time. Please you take care. Heap sort is starting. Right? Please listen now. We done really extraordinary hard work until now, right? Please be comfortable from now onwards. See this? See everyone? See everyone here? See this one, heap sort. Heap sort is completely based on one small keyword that is called as, see this one, heap tree. Heap tree. Heap sort is based on, right, heap tree. Next one, heap sort is based on heap tree. So I written here, that's fine. So heap trees are two types. First one is going to be max heap tree. Max heap tree. Second one is going to be min heap tree. First one is max heap tree, second one is going to be min heap tree. Heap trees are two types, max heap tree and min heap tree. Some people are asking, sir, what is the difference between them? First learn one thing, automatically second one will get. Learn the first thing now, max heap tree. Right, max heap tree, I am writing the definition also, please see. In the given almost complete binary tree, see this one, in the given almost complete binary tree, at every node, in the given almost complete binary tree, at every node, root is maximum or equal comparing its children. In the given almost complete binary tree, at every node, root is maximum or equal comparing its children, then it is max heap. Then it is max heap tree. Right, this is the definition. Then it is max heap tree. Roughly I written. Heap trees are two types, max heap tree, mini heap tree. In the given almost complete binary tree, at every node, root is maximum or equal comparing its children, then it is max heap tree. So same definition, see this one, same definition. What are the only change? Root is minimum or equal, same thing. As it is same, see this one, root is, what is that one? Minimum or equal, minimum or equal. At every node, root is maximum or equal comparing its children, that is called as max heap tree, mini heap tree, everything same, right? Root is minimum or equal, in this place change, then it is going to be a mini heap tree. Okay, I think heap trees are two types. I think I clearly written definition. I will give example. See the example. See the example now. See everyone, everything is ready, right? See this one, I will check it is a max heap tree or not, I will check. What is the max heap tree definition? At every node, root is maximum or equal. At every node, not one place, two place, at every node, root is maximum or equal. Please be careful, right? I am starting, see this. I am starting this. Root is maximum or equal. See everyone now. At every node, root is maximum or equal comparing its children. See the answer. It is the 2, it is the 5, what is this? At every node, root is maximum or equal comparing its children. Can you say 2, 5? Who is the maximum? 5. So it should be 5 or more than 5. What is the reason? Root is maximum or equal comparing its children. 2, 5, which is the maximum? 5. It should be either 5 or more than 5. I will take 10. If you want, you can check. Root is maximum or equal comparing its children. See, it is a 10, then also okay. Equal also okay. But one thing, root will be maximum or equal comparing its children. Same thing here. 1, 2, this one. 1 and 2 maximum 2, it should be 2 or more than 2, I am writing 5. Some people are asking already 5 there, it doesn't matter already 5 there or not there, it doesn't matter. That is the definition. Next one, it is a 5, it is a 7, what should be? 7, 5 larger, 7, it should be 7 or more than 7, 15. Next one, it is a 3, it is a 30, what it should be? 30 or more than 30, 40. It is a 10, it is a 40, it should be 40 or more than 40, 50. It is a 15 and it is a 50, larger 50, it is a 50 or more than 50, 60, right, like that. At every node, see this one, at every node, root is maximum comparing its children. Root is maximum comparing its children. Root is maximum comparing its children. Everywhere it is satisfied. Now can you help me one small line now? So I given one example to you. Please help me, right? Is it max heap tree or not? What is the max heap tree definition? See, in the given almost complete binary tree, at every node root is maximum or equal. Yes, at every node root is maximum or equal. Comparing its children, then it is called as max heap. I thought it is a max heap, but fundamental property I am failing. What is that? In the given almost complete binary tree, it is not a almost complete. See this one gap. Right? Without completing left, how can you go to right? Because of this gap. So what is the answer? First of all, if you want to say it is a max heap tree or min heap tree, first of all it should be almost complete binary tree. Because of it is not a almost complete binary tree, I don't check is it max heap or not. I don't check also. If you want to verify some tree is a some tree is a max heap tree or a mini heap tree or not, first to check is it almost complete binary tree or not. No, it is not almost complete binary tree. Then no need to check. Almost complete binary tree fail means max heap is fail. So see the definition. So this is very important line. Those people who will forget this line, those people will give the wrong answer in the heap trees. In the heap sort, if anyone done mistake because of this only, they forgotten this line. In the given almost complete binary tree, at every way root is maximum or equal, then it is known as max heap. If you forget this one, if you remember this one, right, then guarantee mistakes will happen. So it is not a max heap because it is not a almost complete binary tree. Right? Now some people are asking, sir, can you give one example of max heap? I am giving. See this one, I am giving. Right? If you want to, it is almost complete binary tree. Right? First of all, it should be almost complete binary. Almost complete binary tree satisfied. Now let's go to the root is maximum or equal comparing with the children's. Right? Let's check here. 10, 20. Who is the maximum? 20. It should be 20 or more than 20, 30. Next one, it is a 5, it is a 7. It should be 7 or more than 7, 7. Equal also okay. Next one, it is a 2, it is 15. It should be 15 or more than 15, 15. It is a 7, 30. It should be 30 or more than 30, 35. 35, 15. It should be 30. It should be 35 or more than 35. Right? Maybe 40. So it is almost a complete binary tree. At everywhere root is maximum comparing with the children. See, root is maximum comparing with the children. Root is maximum comparing with the children. Root is maximum comparing with the children. See, not maximum, equal also okay. So it is a max heap tree also. It is a max heap tree also. Please be careful. And one more interesting answer. Is it max heap tree? Yes. Can you say max heap tree is a binary tree or almost complete binary tree? Almost complete binary tree. Almost complete binary tree inside the computer will store how? In the form of array. That is the reason we discussed all these things. Right? See this one. Listen everyone, I have a binary tree which is the almost complete binary tree. What is the way to represent? In the form of array. This will be stored in the form of array. From today onwards, if anyone asks you, I have a max heap tree, how will you store inside a computer? In the form of array. And some people are asking, space may be wasted. No. Because of no gaps there, no space waste also. You may say that in the almost complete binary there is a gap, last level right to left. What is the meaning? After tree over, gaps will come. There is no problem at all. In the middle of the tree, gaps not allowed. If it is there, more gaps will come in the array representation. At the end, gaps are there, no problem. Right? So let me write now. Can you say how this particular max heap tree will store inside a computer in the form of array? Means what? Right? First 40 will store. Next, followed by their children. Who are those? 35, 15. Just write level by level, nothing there. First 40. Next one, their children. 15 and 15. So 35 and 15. Next to 7. Next to 30. Next to 2. Next to 15. Next to 5. Next to 7. Next to 10. Next to 20. Right? These are the array indexes. Right? Like this. Try to remember, min heap or max heap will store inside the computer in the form of array. Please be careful. That is the reason we done until now. Level by level you store because of no gaps in between, level by level. Now again I am asking you, see this one, again I am asking you, what is the topic name going on? Heap trees. Heap trees how many types? Max heap, tree, min heap. Both will be same. Replace max by min, then it will become min heap. Next one, what is the max heap tree definition? In the given almost complete binary tree, at every node root is maximum or equal, then it is called as max heap. right? So this is not a max heap, everything okay, but it is not a max heap. Fundamental property fail. What is that? Almost complete binary tree concept fail. Next one, major thing is that only. Next one. So first of all, it should be almost complete binary tree. Yes. At everywhere, root is maximum or equal comparing with children. Yes. Because of it is almost complete binary tree. Inside computer, it will store in the form of array. How to store array? Just nothing. Level by level you store. Yes, I store. This is something about max heap. Let's go for min heap. See the min heap now. Min heap. One example let me give. Min heap. Min heap tree. One example let me give. Please try to get here itself. Min heap tree. Min heap tree. So it should be almost complete binary tree. Yes, I took. See the min heap tree definition. At every node, not one node, two node, at every node, root is minimum or equal comparing with children. Root is minimum or equal. See this one, root is minimum or equal comparing with the children. Let's check what is the meaning of this. Let's see this one. See everyone now. 20, 30. Who is the minimum? 20. It should be 20 or less than 20, 15. Next one. See this one. Next one. 40, 50. It should be 40 or less than 40, 30. 15, 30, it should be 15 or less than 15, 10. Next one, 60, 70, it should be 60 or less than 60, 20. Next one, 10, 20, it should be 10 or less than 10, 5, right, like this. Root will be minimum or equal comparing with the children's. Not comparing with someone else, comparing its children, root will be minimum or equal. And one more small thing I want to ask you. Can you help me now? Can you help me now? Max heap tree or min heap tree? Max heap tree or min heap tree? How many levels will be there? You know very well. What is the answer? Log n levels. It is almost like complete binary tree only. The only thing is last level few gaps are there. What is the answer? Log n plus 1 base 2 levels. Asymptotically log n levels. Asymptotically log n levels. Same thing here also. Now if you want you can check. Can you help in how many nodes are there? 7 plus 3. 7 plus 4 how many? 11. What is the log 11 base 2? Means log n plus 1. Log 12 base 2. What is the answer? Log 8 base 2 is 3. Right? Log 16 base 2 is 4. Means more than 3. Maybe 4 levels. See. 4 levels. Right? Log n plus 1 levels. Asymptotically log n. Asymptotically log n. Right? Mathematically log n plus 1 levels. Right? More than 3 point something means more than 3. Maybe 4 levels. Asymptotically log n. Now I think it is the correct time to ask you. It is the correct time to ask you. Can you help me now? There is a heap tree. That may be min heap or max heap. There is a heap tree with n elements. How many levels are there? Order of log n. Next one. How the heap tree will store inside computer in the form of array? Why? Right? If the given tree is a complete binary tree or almost complete binary tree, array representation is the best idea. What is the reason? N nodes to store. N slots enough. If it is otherwise, suppose that is not a complete or almost complete, n nodes to store, worst case, 2 power n minus 1 slots you have to take. So that time, right, whenever it is not a complete binary tree or almost complete binary tree, we will go in the form of a linked list, right, don't worry. Until now, whatever you got, it's okay. Can you help me now? Inside computer, how it will store? In the form of array, can you store it? 5, 10, 20, 15, 30, 60, 70, 20, 30, 40, 50, right, like level by level you store. I am thinking you are okay. Now can you help me now? From today onwards if I ask you, see the interesting answer. From today onwards if I ask you, right, from today onwards if I ask you, I am given max heap tree to you. Careful listen, I am given max heap tree to you. If I ask you from today onwards, I am given max heap tree to you which contain n elements. Max heap tree which contain n nodes. If I ask you, how I given? In the form of tree or array? Try to remember, array. This is given. Right? He will ask you, see this one. He will ask you like this one. Consider a max heap tree. In gate examination question will be like this one. Consider a max heap shown in the form of array. Right? He will give this. He will give this. Consider a max heap which is shown in the form of array. They will give like this. Now can you help me one small line now? So both will be same. Actually you are expecting tree, but he may give like this because inside computer it is in the form of array. Can you help me now? Tree and array which is convenient to you. Both are okay, that's okay. Can you say tree and array which is convenient to you? Try to remember if it is a tree there. If I want to find out any person parent, directly I can find out. But in the case of array, I have to apply formula. If I ask you, who is the parent of someone? Here I have to apply formula again and again. Left child again formula, right child again formula, parent again formula, but here no formula, nothing. Here no formula, nothing. This is for user, this is for computer, everyone know that. Right? In GATE examination, question will be like this one. Consider the following max heap, which is given in the form of array. They will give like this. Now as soon as they are given like this one, if you do directly, afterwards you will say something. Max heap tree given in the form of array, yes, afterwards you will say something, right? To do that something, if you do directly here, maybe I think formula you have to apply again and again, small mistake maybe you will do, best idea, as soon as max heap is given like this one, immediately by taking 1 minute, draw the diagram like this. Right? Because tree is best to us, because no need to apply formula again and again. Otherwise you have to apply, if you do small mistake also in the end, right, in formulas, you may get wrong answer. On max heap or mini heap, any question is K, they will give in the form of array. Right? From that array to tree format you write first. Afterwards you do on that tree. You will say something afterwards, right? On that you can do that. In GATE examination, this question is given, what answer you are going to give? Just listen, just listen. There is a max heap tree in exam, question is like this, what is the answer? There is a max heap with n elements in the form of array. In the by default array only. If we say array, it's okay, by default also array. There is a max heap with the n elements in the form of array, that's fine. Right? Both are same, you consider whatever way you want. My advice is please go in the form of a tree, that is okay. Now he is asking, you have a max heap which contain n elements in the form of array, that is fine. Now the next question is going to be, in that max heap to find out first maximum element, how much time? Right? In that max heap to find out first maximum element, how much time? What is the answer? Everyone knows. See this one, everyone knows. See this one, interesting answer. See this one. It is a max heap tree. It is a max heap tree. In this max heap tree, see this one. This subpart also max heap. Total thing is a max heap, means subpart also max heap. See this one. This is also max heap. It is a max heap. Please help me now. If it is a max heap, see this one. Comparing children's, parent is bigger. Here also comparing children's, parent is bigger. Comparing these two children, his parent is bigger. Are equal also okay. Comparing these two children, this parent is bigger. Same way, comparing these two children, this parent bigger. Comparing these two children, this parent is bigger. I think problem is over. Can you help me now? Max heap tree is given in the form of array to find out first maximum element. How much time? What is the answer? Root itself is first maximum. Because root is maximum comparing with children. Right? So see this one, you only say comparing these two, it is maximum means. Right? Same thing here also. Comparing these two is maximum. Comparing these two is maximum. Everywhere same story happening. In the max heap tree, which is given in the form of array, to find out the maximum element. What is the answer? Root itself, which is nothing but first element itself. Can you say how much time? Return a of 1. That's it. Max heap tree is given with n nodes in the form of array. To find out the maximum element, how much time? What is the answer? Return a of 1. First element itself is root. First element itself is maximum element. In the max heap, to find out the maximum element, what is the time complexity? Order of 1. Which case? Right? Every case, because root itself is answer. In max heap, to find out maximum element, constant time. Right? Please be careful. Let me write here. I am writing here. See this one. Max heap. Right? Max heap. See this one. Max heap. To find first maximum. Max heap to find first maximum. Max heap to find out first maximum. Can you see how much time? Root itself. Can you see how many people are participating? In the max heap tree, to find out first maximum, how many people are fighting? Only root. Only one person fighting means how many comparison? Zero comparison. What is the time complexity? If zero comparison, what is the time complexity? Constant time. Right? Like that. Fine. I'm thinking you are a little bit okay. Now let's see the interesting answer. Let's see interesting answer. Don't confuse. Let me remove this. In max heap, to find out first maximum, how much time? I think one person fighting, zero comparison, time complexity constant. I'm really fine now. Listen, I'm really fine. See the answer. In max heap tree, see this one. In the max heap tree, you only say to find second maximum. What is the story? In max heap tree, to find out second maximum. What is the story? See this also. In max heap, to find out second maximum, see this one, I think is the first maximum, already fine. Is the first maximum already fine? Can you say who is the second maximum? Please try to remember, if it is the first maximum, second maximum purpose, both the left and right both will fight, right? Left also, from the left group he will say that I am the second maximum, from the right group he will say that he is the second maximum, but I want I think nothing there. Second maximum purpose, try to remember, two elements will fight, these two will fight. Just do one comparison. Two elements means how many comparison? One comparison you do, which is bigger, 35 bigger. So I think to do one comparison, constant time, then is bigger. Second maximum purpose, two elements are fighting. Who are those? Parent left child, parent right child. Both will fight. Whoever is bigger in that, right? That will go to second maximum. I think one comparison, constant time. That is also okay. Now listen, interesting answer. See this one, interesting answer. Third maximum. To find out third maximum, you only say, to find out who is the second maximum, this one. Second maximum is this one. See the answer. To find out third maximum, what is going on? See this one. I think these two people, see 35-15 already fighted. 35 is the winner, it's okay. He is the loser, he will fight for third minimum. Because the second minimum fail, right? He will try for third minimum, but one thing, right? He himself fail means further people cannot pass. That is the reason he still fight. He will say that I fighted for second maximum, I failed, I may be third maximum, right? He want to fight. Can you help him? With whom he will fight? Because of he is the second maximum, right? Their two children will come for, right? Third maximum. So these two and the second maximum loser, these three will fight. So what I want to say, third maximum purpose, three people will fight. If three people, who are those? 7. Whoever is winner, their two children will come, right? Whoever is the previous loser, that person. 7, 30, 15. Can you help me? 3 people means 2 comparison. How much time? 2 comparison, constant time. This is going on like that. Can you help me now? See, second maximum, every time what happened is 1 is increasing. See this one. Third maximum, 3 people. If you want, you can check. Fourth maximum, 4 people. 3 comparison, constant time. Right? It is going on like this. It is going on like this. Please be careful. Fourth maximum. Fourth maximum, 4 people are fighting, 3 comparisons, constant time. It is keep on going. Can you help me? Interesting line. This may be confuse you, but it is a fact I have to say. See this one. 10th maximum purpose. How many people are fighting? 10 people. 10 people. Can you see how many comparison? 9 comparison. This is also constant time. That is fine. Right? So see this one. In one of your previous paper, this question is given. What the answer you are going to give? Max heap tree which contain n nodes. To find out maximum element, how much time? How much time? Constant. Why? To find out the maximum, root itself, return that element, constant. Can you help in a second maximum? There are 2 children, just compare, right? Just 2 people, 1 comparison, constant time, right? Third maximum, right? Like every time what happened is 1 person is winner, he will go, their 2 children will come. Means 1 going, 2 coming. What is the meaning? 1 extra coming. See this one. I think if you see this one, 35 went, their 2 children came. Can you help me? What is the third maximum? 7, 30, 15. Who is the maximum? 30. Next one, 30 will go, their 2 children will go. See, 30 parent will go, their 2 children will come. 1 going, 2 coming. I think 1 extra. So like that. Every time 1 will go, 2 is coming. Means 1 extra coming. 1 extra coming. Like that you keep on compare, you will get the first maximum, second maximum, third maximum and so on. But one thing I want to ask you. Listen, this will trouble you if you don't listen. Can you help me? 10th maximum purpose, how many people are fighting? 10 people. First maximum purpose, 1 person fighting. Second maximum person, 2 people. Third maximum purpose, 3 people. 10th maximum purpose, I think 10 people are fighting. 10th maximum purpose, 10 people are fighting. Right? So out of those 10 people, to find out the right maximum element, 10 people fighting. To find out maximum person, 9 comparisons required. 9 comparisons is a constant time, that is also okay. But one thing, 10th maximum purpose, 10 people are fighting, which is going to be 9 comparison, which is going to be constant time, that is also okay. But one thing, 10th maximum purpose, 10 people are fighting. Who are those 10 people? In the tree, 10 people fighting, I am okay. But who are those 10 people? Directly how to get those 10 people? That is the reason I am saying to you, if you want 10th maximum, first maximum find out, second maximum find out, third maximum find out, means you should do this entire work. 10th maximum purpose, 10 people fighting, 9 comparison, that's okay. But previous things also you have to do. Otherwise how will you get directly those 10 people? So final conclusion is this one. See this one, 10th maximum to find out 10 people fighting means 9 comparison, that's okay. But one thing, directly you cannot do, you have to start from here. What does it mean? All you have to add, then total work will come. See, 10th maximum to find out, this much work you should do. Can you see how many? 10th maximum purpose, sum of 9 natural numbers. See, 1 plus 2 plus 3, add all of them, sum of 9 natural number, 9 into 10 by 2. 90 by 2, what does it mean? 45. 45 also constant, right? Order of 1. That is the answer. This is the fact. 10th maximum to find out. 10 people are fighting. 9 comparison. But one thing, starting onwards I have to do. So, sum of 9 natural number. What is the formula? Sum of n natural number, n into n plus 1. 9 natural number, 9 into 9 plus 1. 9 into 10 by 2, which is 45, which is a constant. Can you help how to find out in max heap tree? How to find out in the max heap tree, 50 maximum. What is the answer? 50 maximum purpose, 5 people are fighting. Who are those 5? From starting onwards you have to do. Sum of 4 natural number. Why sum of 4 natural number? First time 0 comparison. So next time 1 comparison. 5th time 4 comparison. Sum of 4 natural number you have to do. See this one, 5th maximum. Right? 5th maximum. 5 people fighting. How many comparison? 4. So this one you have to do. Sum of 4 natural number. From all these, see the final conclusion. See the final conclusion. See the answer. See the final conclusion. In max heap to find 10th maximum. Can you help Total comparison how many? Sum of 9 natural number. 9 into 10 by 2. 90 by 2. 45, which is going to be constant. Just remember, in max heap to find 10th maximum, these many comparisons are required, because starting onwards you have to do. That is the thing what people are missing. In max heap to find out 10th maximum, these many comparisons are required, constant time. First maximum, second maximum, third maximum, try to remember the approach whatever I said to you. This is the good idea, right? This is the good idea. If you go until constant elements, 10th maximum, 20th maximum, 50 maximum, first maximum, constant, this is the best idea. Supposition that, right? Supposition that in the max heap, I want to find out nth maximum, then what is the answer? Sum of n minus 1 natural number, n square will come. This is the best idea if constant elements. Constant only this approach is better. Can you help in a max heap? First maximum to find out how much time? Constant. Second maximum, constant. Third maximum, constant. Like that you can give. Actually third maximum how many comparison? Sum of 2 natural number. 2 into 3 by 2, 2 comparison. Constant time. Right? This is the worst idea if you want to find out nth maximum. Nth maximum how many comparison? Sum of n minus 1 natural number. N minus 1 into n by 2, n square. So that is the worst idea. Please be careful. Listen now. Again I am asking you. See the interesting answer. Max heap tree to find out first maximum. Order of 1 time. Second maximum. Order of 1 time. This story will continue until constant elements. Constant element, this approach is better. When function started, this may not be better. Right? Fine. I am thinking that you are okay. See this one. Max heap tree definition I said. One or two examples I given. Min heap tree also similar story. Can you help in max heap tree? Who is the root? First maximum. Next, there are 2 children, 1 person. Next maximum. Like that, 1 person will go, 2 will come. Whoever is winner, we will go. Their children will come. So every time 1 extra coming. To find out 10th maximum, right? 10 people are fighting, 9 comparison. So from starting onwards, 1 to 9, sum of 9 natural number, which will goes to this is the answer, constant time. This approach, whatever approach I am discussing from the last 5 minutes, that is a good idea for, right? If you want to find out constant maximum element, 10th maximum, 50 maximum, first maximum, second maximum, something like that. It is not good for function, right? Fine. Okay. Now listen. Interesting answer. See everyone, interesting answer. In max heap tree, to find out first maximum, second maximum, third maximum, constant, it's okay, right? Now can you help me one small line? Interesting answer. Can you help me one small line? In the given array, listen everyone, in the given array, to find out first maximum, how much time? Given array. I am not asking max heap. In the given array, to find out the first maximum, how much time? What is the answer? In the given array, if you want to find out the first maximum, right, what you have to do? I think finding max-min algorithm, right? One time you have to apply one loop, just scan, find the maximum element. In the see this one, in the array, in the normal array, to find out the maximum element, one scan required, order of n time. Can you help, in the normal array, to find out second maximum? I think same max-min algorithm, one more round you have to do. Find first maximum, delete, right? One more round you do, second maximum. Find first maximum, find second maximum, find third maximum, like that, right? In the normal array, to find out the first maximum, order of n time, second maximum, order of n time, third maximum, order of n time. Please be careful. In the normal array, that is the story. But in the max heap tree, assume that you have a max heap in the form of array. See this one, it is the max heap array. You have a max heap in the form of a array. In the max heap tree, to find out the first maximum, constant, second maximum, constant, third maximum, constant. That is the advantage with the max heap. See this one, max heap also array, normal array also array. Can you help now? I have a max heap array, I have a normal array. Which is better to find out the maximum? Normal array I have, max heap array also I have. To find out the maximum, who is better? Max heap. Max heap is meant for that. If you want always maximum, right? If you have a max heap, that is a better idea. Right? If you have a normal array, to find out the maximum, one scan required n time. Right? One more maximum, one more scan n time. In the normal array, to find out maximum, every time n required. But in the max heap array, to find out the maximum, every time almost constant required. Max heap is the great idea if you want always maximum element. In the similar way, min heap array is the great idea if you want always minimum. Min heap array is the great idea if you want always minimum, right? See this one, let me go here. Min heap array is always better idea if you want always minimum. If you want, you can check. See this one, in this group, E is minimum. In this group, E is minimum. Comparing these two people, E is minimum. See this one, in the min heap array, minimums are very cheaper. In the max heap array, right? Maximums are cheaper. In the normal array, everything is same cost. You can say in the normal array, how to find out minimum? One scan required. How to find out maximum? One scan. In the normal array, right, minimum also required one scan, maximum also required one scan. But in the min heap array, minimums required constant. In the max heap array, maximums required constant time. Please be careful. Max heap tree is created for that purpose only. I want always maximum with the cheaper cost, then go to max heap. I want always minimum with the cheaper cost, then go to min heap. Suppose I have normal array, nothing is cheaper, right? You have to do same amount of work. Scan the entire array, find maximum, one scan. Scan the entire array, right? Find the minimum, something like that. Right? Please be careful. Max heap tree is meant for maximum element, min heap tree is meant for minimum element. Can you help to find out 10th maximum? How many comparison? Sum of 9 natural number, 45 constant. In the similar way, to find out the 10th minimum, same story. First minimum, one person fighting. Second minimum, two people fighting. Third minimum, 3 people. 10th minimum, 10 people will fight. Means 9 comparison, sum of 9 natural number. Same thing will happen. It is meant for minimum, it is meant for maximums. Right? I'm thinking you are okay. Right? Fine. Now see the interesting answer. One small thing there, let me say with this also, then problem will be over. See this one. One note I written. In max heap, to find out 10th maximum, constant time required, that is fine. I'm okay with that. I'm okay. See the answer. Can you help in the max heap, in the max heap, constant time it's okay. First maximum, second maximum, constant time, I'm okay. In the max heap tree, to find out, right, to find out nth maximum, how much time? In the max heap, to find out nth maximum, how much time? Nth maximum, what is the answer? Sum of n minus 1 natural number, how much? N minus 1 into n by 2, how much? N square. But one thing is true, listen, listen everyone, in the max heap tree, nth maximum is nothing but minimum element. First maximum means first maximum, second maximum, third maximum, nth maximum means minimum element. Try to remember, in the max heap, you want to find out minimum element. Actually max heap is meant for maximum element, but you want to find out minimum element. Can you help me now? In the max heap tree, where will be the minimum element? Right? Definitely in the max heap tree, minimum element will be there. See this one of the leaf node. One of the leaf node is going to be minimum element. In max heap tree is meant for maximum element. But when you try for a minimum element, I think minimum elements are there in the, right? One of the leaf node is going to be minimum. Can you read the leaf node? 5, 7, 10, 20, 2, 15. Which one is minimum among them? 2. 2 is minimum. Can you help me now? Max heap tree first maximum, constant. Max heap tree second maximum, constant, and so on, and so on. Like constant elements, okay. But max heap tree nth maximum, it will become like this. If you do n square, it will become. Try to remember, max heap tree nth maximum means minimum element. Minimum element. Max heap tree is not meant for minimum element. Max heap tree meant for maximum elements only. But one thing, in the max heap tree, where is the minimum element? Last level. Can you help me now? Right? Leaf nodes how many? In the complete binary tree or almost complete binary tree, leaf nodes how many? N by 2. N by 2 leaf nodes are there. Right? N by 2. See this one? N by 2. I think almost like half. Assume. Can you help me? If you want, you can check how many nodes here. 7 plus 3, 7 plus 4, how many? 11. 11 by 2, how much? 11 by 2, 5 point something, right? Take the ceiling value, it will become 6, right? I think 6 are going to be leaf nodes. See, these leaf nodes, 6 people. From this side, 6 people. How many? I think here, until here. Right? Until 6 people. See this one. In this max heap tree, which contain 11 nodes, I want to find out leaf nodes how many? 11 by 2, 5 point something, 5.5. Take the ceiling value 6. I think 6 people. In these 6 people, carefully listen. In these 6 people, one person is going to be leaf node. Oh, sorry, one person is going to be smallest element. Now it's the correct time to ask you, please help me. Max heap tree is meant for maximum element or minimum element? Maximum element. How much time? Constant. Next maximum constant, something like that. But it is not meant for minimum element. If you try to minimum element with this approach, it will become n square. But one thing is true. Max heap tree, to find out the minimum element, one way is n square there. Like this is n square. Right? So one more way is, let's see possibilities you see. Max heap tree, I want to find out minimum element. Max heap tree, I want to find out minimum element. One way, find out first maximum, second maximum, third maximum, which will goes to n square. One more way is going to be, max heap tree is a first of all array. See the ways now. Max heap tree, to find out the minimum element, one way is n square. One more way is, max heap tree is a first of all array. In that array, do one scan, find the minimum element, which will take n time. So on max heap tree, to find out the minimum element, one way n square, one more way is n, which is better? N is better. Always you remember, anything is given, at that point of time, how many possibilities? In that best one you take. One way is what? Do like this one. First maximum, delete. First maximum, right? Next maximum, their children will fight, like this if you do. Right? To find out the maximum element, to find out the minimum element in the max heap, n square one way. One more way is, max heap tree first of all array. In the array, do one scan, find out minimum element, which will take order of n time. Some people are asking, right? If I do like that, normal array and this one, what is the difference? Try to remember. This array, normal array, no difference if you want minimum element. Normal array, max heap array, both are same, because you are finding on the max heap something which no use. If use is there, take. Use not there, don't take. Now it is the correct time to ask you. Please listen. Listen everyone. Max heap tree array I given. It is meant for maximum element or minimum element? Maximum element only. Max heap tree array I given. If you want maximum, first person you take, constant time. But max heap tree array given, I want minimum element. In the max heap tree, minimum, no relation. If no relation there, just I think, okay, this is not useful, normal. Anyhow, it is array. Just to do one scan, find out minimum element. Because of you are really comfortable. Final conclusion. Max heap tree, to find out first maximum, constant, second maximum, constant, third maximum, constant, 10th maximum, Sum of 9 natural number, that is also constant. Until constant time it's okay. But when function came, it may not be better idea. Right? So can you help in the max heap to find out the minimum element? I think minimum means nth maximum, no use. Then what is the answer? Whenever, no use. First of all, it is a array. Right? Just to do one scan, find out minimum element. Now let me write now. This is the one point you take care. See the second point. Interesting point. See the second point in max heap. In max heap with n elements. With n elements. In max heap with n elements to find see the interesting answer, minimum element. To find minimum element. In max heap with n elements to find out minimum element. Max heap and minimum element no relation, but one thing, max heap is a array. In the array finding minimum, one scan enough, order of n. Available answer, best answer you take. Some people are asking in the normal array also to find out minimum same time. In max heap array also to find out the minimum same time. Why? Max heap is meant for maximum. You want minimum, no use. Right? No use. Please be careful. Use is there, take. Use not there. Previous existing algorithm, can you help before today's class, before this class to find out maximum, how much time? One scan, n. To find out minimum, how much time? One scan. So before this class, whatever you know to find out maximum, minimum, that one you have already. Now because of this class, if something new will come, compare both, old one, new one. Okay, new one looking better, you take. Suppose assume that, right, new one is not good for this, take old only. Yes, until last class, maximum one scan required, minimum one scan required, n time. Now because of max heap array finding maximum one. Max heap is not useful for minimum, previous things only, it is the previous algorithm which you know very well. So this is the new point, max heap to find out 10th maximum, right, 10th maximum, constant maximum, please be careful, constant maximum. Constant maximum, so what is the answer? Constant is, if 10th maximum means sum of 9 natural number, right, suppose in the 25th maximum, sum of 24 natural number, which will leads to constant. But when you say max heap, minimum element, no relation. First of all, max heap is a array. So just to do one scan and do that. In one of the previous paper, this question is given. Max heap to find out minimum element, how much time? What is the answer? N. Why? Max heap, minimum element, no relation. First of all, max heap is a array. In the array, scanning and finding the minimum element. Same thing will happen with the min heap also. Min heap minimum, constant. But min heap maximum, order of n. This is given many times in the previous paper, please take care. If you give n square, there is no use. See, two algorithms, there is n square also possible and n also possible, then why don't you go for better algorithm? Always better algorithm is expected. Always better algorithm is expected. I am thinking you are comfortable. See, this story also please take it. Some students will think that 10th maximum purpose, 10 elements fighting, 9 comparison, only 9 comparison they will think. 10th maximum purpose, 10 people fighting. Who are those 10? How you know? In this much big diagram, who are those 10 people? If 10 people you know, you can compare. Who are those 10 people? Because of you don't know, starting onwards you do. So sum of 9 natural number. 10th maximum purpose, 45 comparison, constant. But one thing, max heap for maximums, but you want minimum. No relation, then I think one scan which will goes to order of n. Can you help me one small line? One more better idea. Max heap, if you want to find out minimum, max heap tree, if you want to find out minimum, right? Can you help where is the minimum? Because of it is the max heap, all the top people are maximum, below is minimum people are there. What is the meaning? Leaf nodes. These are leaf nodes. In this leaf node, one of the leaf node is going to be your answer. Some people are asking, sir, how to find out leaf nodes? What is the answer? N elements are there, half is going to be leaf, half is non-leaf. If fractions will come, give bigger fraction to non-leaf. So 11 by 2, 5.5, which will become 6, right? I think last 6 people. In these 6 people, one person is going to be smallest element. So how many people? Leaf node, half, n by 2. N by 2 people, compare, you will get the minimum element. One answer is, right? One answer is going to be max heap minimum no relation. So max heap is a array. Total array scan. Find out the minimum element. That will goes to almost like n comparison. One more better idea. Because of it the max heap, top level max people, So I think leaf nodes are minimum people. I don't know which leaf is minimum, but leaf nodes are minimum, right? How many leaf nodes are there? N by 2. In N by 2 only find out minimum, which will goes to N by 2 comparison. Asymptotically that is also order of N. But if you go like this, what is the answer? N minus 1 comparison. One scan required N people. First one is compared with all other people. So that is one more answer is going to be half people only compare. See, so here N people comparing. In max heap with N element to find minimum element, order of N time, N elements compare. This is one idea. One more answer is going to be, right? So because of it the max heap with N elements, you want to find out the minimum, only leaf nodes compare. Only leaf nodes compare. How many? N by 2. N by 2 elements compare. Right? Which will goes to how much time? N by 2 comparing approximately order of N. This is also order of N. 3 algorithm. One worst answer, N square. Right? To this, see this one, to this problem, one worst answer is N square, no use. That is the reason I didn't return. One more worst idea. If you want to find out in the max heap minimum element that is there, one of the leaf node, then why are you comparing non-leaf also? Compare here everyone, right? Leaf and non-leaf you compare, then also N will come. Only leaf nodes compare because max heap tree minimum, leaf node only, N by 2 leaf node compare them, right? This is also answer. Both are correct. This also correct, this also. Comparing this one, it is far better.